Hi there, so I thought I would do a video on the DM-15L and compare it to some algebraic calculators, and also to have a little think about whether this calculator would be suitable for use in school and for the exams in the UK. I've done a previous video on RPN and algebraic, but this one's just a bit of a deeper dive. So let me show you the calculators. So we've got our DM-15L with the latest firmware. It's got 2-line display now. Our oldest algebraic is this FX992S. I think this is from the 90s, early 90s. And then we've also got an FX115W. This was when Algebraics moved to the 2-line display, so sort of dot matrix on the top and segmented display on the bottom. And then I've also got one of the sort of math print style ones, which allows you to make it essentially look like the formula that you would find in a textbook. This is a very common one for school, so I think it's a quite good one to compare them to. I haven't gone for the absolute oldest type of scientific because I think this one is probably as far back as you want to go, and actually it works similarly to the sort of the ones before. It's just we've got an enunciator in the corner, which helps a little bit. Okay, so what I thought we'll do is have a look at two puzzles. And right, let's have a look at these then. So the first puzzle is this one here, which is the filling puzzle. So this is the question. The diagram shows a tank in the shape of a cuboid. It also shows 3 cylinders, shapes of cylinders and cuboids. The tank is full of oil. The containers are empty. 35% of the oil from the tank is spilled, and the rest of the oil from the tank is poured into containers 1, 2, and then 3 in that order. So you want to know the height of the oil in the last container, and then give your answer to an appropriate degree of accuracy. This is actually adapted from a GCSE maths paper question. It's made a little bit more complicated. Right, so let's have a look first on the RPN. Right, so okay, so we've got the tank first. So first thing to do is work out the volume of the tank. So we've got 120, 105, 78, all multiplied together, and we get that. We probably don't need 4 digits of precision there, so there we are. So 982,800. We've lost 35%. So type in 35, percentage button. And one really nice thing about algebraics is the way it does percentages, is it leaves you both numbers to do what you like with them. So I can add that, I can subtract it, or I can just forget about the original result. In this case, we've lost 35%, so I can subtract it. And we got 638,820. Okay, so that's how much oil we're dealing with. So the next step is, let's work out the volume of container 1. So it's an 80 centimeter diameter, divide it by 2 to get the radius, square it, times it by pi, and now we've got the surface area. We've got the area of the base of the cylinder, times it by 70, and that's how much volume we've got, 351,858 centimeter cubed. So I'm going to subtract that from the amount of oil, and we're moving on to container 2. 60 times 60 is the base. Just as a convenience function, we can just press enter and it duplicates it, times it by 100, so we got 360,000 there. And I was about to take that away from the amount of oil we've got left, but we can see that it's actually a bigger container than what we have left. So it's not going to fill up container 3 because of the spill. So let's work out how far it is going to fill up container 2. 60 times 60 again. We don't want the height. Well, we're trying to work out the height, so divide that, and it's 79.7. So it's going to be 79.7 centimeters up container 2. Right, let's start with the oldest algebraic. Obviously, this is a bit of a a biased comparison because even though I grew up using algebraic calculators, I'm a big fan of the RPNs now. Okay, so so let's start off first. So I'm going to do 120 times 105 times 78. That gives me the same answer. Now then, I guess with algebraics you've got a choice. You can either try and chain your calculations, or you can try and formulate it into a big formula right from the off, and try and fit it all onto there. I think there are pros and cons of doing both, and actually different calculators manage things in very different ways. So I'm just going to go with my gut and see how we do this. So 982,800, so we need to lose 35% of that. Now, percentages on algebraics can be quite variable. We've got a percentage button here. So, I don't know, we can just try minus 35%. I don't know if this calculator will actually do that. No, that, I don't know quite what it's done there. Why has it done that? That doesn't, all right, okay. All right, let's try that again. Times 105 times 78. Okay, so it didn't do, some calculators will do it like that. This one doesn't. All right, well, let's store that. Let's put it in the memory. So we've got 1 minus 0.35, so we're going to want 65% of that, so I need to just times that by what we've stored in memory, and there we go, we've got the answer. Weirdly, some things are a bit more manual in algebraic calculators compared to RPN, whereas most things are more manually done in RPN, I think. Okay, so let's store that. Let's go on to container 1. So we've got, let's do a bracket, 80 divided by 2. I'm going to square that, times it by pi, times it by 70, equals that. Okay, so now I need to subtract this from what is in the memory. This is one thing that I find annoying about all algebraics, doesn't matter the type, is that I've got a minus button here, but I can't change which way round I'm subtracting. So I need to subtract this from what is in the memory, but I can't exactly. Okay, what we can do, we can make use of the answer button. So I can do memory recall and then subtract the answer, and hopefully. All right, so I don't know if you saw what happened there, but when I pressed answer, it's actually returned the same number. And of course, subtracting them makes it equal to 0. Okay, so that is very frustrating. I wouldn't have, so it clearly treats memory recall then as an answer, and therefore it wiped out the calculation that I'd done before. I don't really want to go on to using more than one register for memory. So let's do this. We're going to try again, subtract, and then we're going to have 2 brackets because 8t divided by 2, close brackets, square that, times it by pi, times it by 70, close brackets. Okay, we've got a nice interim result there, which is quite nice about this calculator. And if I hit equals, I think this should give us the amount left over. I think that's correct. So I'm going to store that now. And let's move on to container 2. So 60 times 60 times 100. And that is higher than what's in memory. Okay, so I'm going to do what we did, same as the last time. Divide this value by 60 times 60. And we've got 79 centimeters. So we've got the same result. Okay. Let us move on to a few years later when Algebraics introduced the one-line formula along the top. All right, let's just go straight into it. 105 times that times 78, got 92800. We want to lose 35% of that. Now, I'm fairly sure this won't work again, but why not? Let's just give it a go. No. Okay. Let's do that again. I know some different algebraics do the percentages in different ways. I think the sharps would do that calculation actually. Okay, so now we're going to times that by 1 minus 0.35, and that's equivalent of removing 35%. And we've got our the amount of oil left after the spill. Okay, so let's store that then in memory. We've lost one of the memory buttons here, so we don't have the memory in anymore. We've just got the memory plus, which is a bit of a shame, unless maybe I can do store. Yeah, okay, so I can do store and then M plus, there we are. Okay, so we've got that. We now need to work out the size of container 1, so I'm going to put a bracket there, divided by 2, square that, times pi, and then times by 70. It's equal to that. Again, I want to subtract this from what is in the memory. So again, this is a little bit awkward, but very easy to do on RPN because you just swap the X and Y registers. So I could just store it somewhere else. So we could just store it into, let's see, can I store it into A? No. No. All right, that's not. Store into 1. No. Store it into, oh, did something there. Store into A. So, okay. I think that, so recall A, yeah, there we go. We can store it into A, B, C, D, E, and F. Okay, so now we can recall memory, recall A. We've got that. Oh no, what's gone on there? That does not look right. This is one of the other things you have to be a little bit careful of when you're using answer to chain calculations on an algebraic calculator. And that is that sometimes you don't know what that answer is. On an RPN, it's usually the absolute value. On algebraic, it can be a number of things, like the last thing calculated. And exactly what is the last thing calculated is sometimes not that clear. There are some algebraics that do use the absolute number, but the reason they use A and S is because it gets a bit unwieldy. You know, if you put 12 digits into the top line up here, it's very hard to see your formula. And so you've got to be very careful. So if you hit equal again, you know, it's just going to keep going. So you've got to be a bit careful there. So I wonder what's gone on this time. So did memory. So I'm gonna, and then if I look in A, yeah, these are all correct. So if I do recall that minus recall that, you would have thought this would give you the answer, but that. So I think what's going on is that when I hit minus here, I think I'm minusing what I'm seeing here, but I'm not. I'm minusing what the last answer was, which is funny. So, okay, so can I do, so there's another way. Okay, if I do m minus a, this is probably the way you're meant to do it. Yeah, now we get the answer. Okay, good. So I'm going to store that now in the memory. Okay, so the next one, so we know already from previous calculations, you know, let's just do it again, times 100. We know this is too much, so we're gonna, now I keep doing this, but actually I want to press alpha M, because clearly that's the way you meant to do it. And then we're going to work out, oh, actually, that is divide, there we are. And there's one of the advantages of algebraic, is being able to change what you do. That does not look right. All right, what has gone wrong then? Was that right? Maybe, no, we definitely had 79 before. Okay, I've gone wrong somewhere, right? Don't know what I've done there. Okay, let's try and write it up into a big formula. You see, now already we run into some slight issues, because when you do parentheses, you sometimes have to go all the way back, switch to insert mode, put a parentheses there, and then go back again. So you want that, I wanted all that together. Another one here, minus 0.35. So that is going to be what's left after the spill. I'm going to have to put that all in brackets again. Switch to insert mode again. Oh, that didn't work. There we are. This is what I hate about algebraics. So that's now all in brackets. We've now got what oil we have after the spill. I'm going to subtract what's in container 1. So 2 brackets, 80 divided by 2, square that. Are my eyes deceiving me? Where's this? Oh, there we are. Square times pi. Okay. Times it by 70. Good. Okay. And then should we just go straight in, divide that by 60 times 60. Well, that didn't go right, did it? Let's delete this bit. I thought we were doing quite well there. Okay, we've got 2 brackets there, so I'm subtracting that. See what we get for that. Oh, we need 1. Do we need no? Yeah, that is the right answer. Okay, so let's store that into memory. And then we want to divide that. Divide that by 60 times 60. Yes, we've got the right answer. I don't know what went wrong there. I'm not going to blame the algebraic for that. That was definitely user error. Okay, and then lastly we've got the Casio. So the FX85. So this is the math print one. Gotta admit, I'm less familiar with this way of inputting data. All right, so we've got a choice. We can either try chaining things. Let's do that first. So 982,800. So times. Now I know that percentages don't work in the way that I think they do, or think they should do, but that's all right. We know you do have to learn the quirks of your calculator. That's how much it is after the oil spill. So now we're going to subtract container 1, 2 brackets. Do we want 2 brackets, or we can use a fraction, can't we? No, we can't. Okay, 80 divided by 2, and then that's squared. Now we do need another bracket there. Insert mode, put a bracket in, square that, times it by pi. Okay, there we go. And times it by 70. And that should give us what's left over after container 1, that's right. Okay, and then, right, we're going to why don't we just go straight in and divide that by 60 by 60. So I don't know whether I can just, okay, I can put the answer in the top here. Now I am looking for the answer button. There we go, answer, and then we can do 60 times 60 on there. And there we go. Okay, so that's kind of interesting. I struggled a bit with algebra. I mean, part of it is just simply that I'm not that familiar with these calculators. But some of it really is just that it is a bit tricky sometimes to work out how you think the calculator is going to work. Let's move on to the next one. So the next puzzle, the second one, is this one here. So this one's just made up. It's actually a real world situation. You've arrived at work with a range warning in your electric car. It has 15% battery left on your dash. There are electric chargers at work, but they are pricey, and you want to avoid spending a lot of money by filling up the car with their electricity, but you need enough to get home. So you plan on setting a timer on your phone to remind you when to ask your car to stop charging. So some of the facts that we know. So you are 60 kilometers from home, so you need to get home. When you stopped, your car was using 30 kilowatt hours per 100 kilometers on the morning run. Obviously, these units are completely different in every car, which is a bit annoying, isn't it? Your car has 15% of a 64.7 kilowatt hour battery left. And the app states that it is charging at 11 kilowatts when you plug in your car. And you want to give yourself 20% extra to give yourself a bit of leeway. All right, let's have a look first on the algebraic. So now I'm someone that doesn't tend to formulate a formula in my mind before I start. I tend to just do things to the numbers. So we have a whole load of numbers here. The first one is that you're 60 kilometers from home. So let's put that in, 60 kilometers, there we go. So I think we might as well, so we're 60 kilometers from home. The first thing in my mind to work out is how much energy do we need to get back home? So we're using 30 kilowatt hours per 100 kilometers at the moment. So if I do 30 and then divide that by 100, and I've left 60 there. So 60 is now in the Z register. So I'm going to divide that, and I'm going to times that by 60. And there we've got 18 kilowatt hours is what's needed to get me home. Okay, so we've got that information. I can just leave it there on the stack, which is something that's really nice about RPN. And then let's go on and work out how much we've got left in the battery. So it says we've got 64.7 and we want 15% of that. So 64.7 kilowatt hours. So two ways we can do this. We could do 15 and do the percent, and it's 9.71. Actually, I need to pull, it's kind of left the 64.7, which I don't need anymore. So what I can do is I can swap them around and pull them down. and that way I've got 9.7, which is how much I got left, and 18, which is how much I need. So I can subtract that. We've got 8.3 there. I want to give myself 20% extra, so again I can do 20%. That's what 20% is. I can choose to add that or subtract it. This time I'm going to add it, and it's 9.95 kilowatt hours that I want. So it says it's charging at 11 kilowatts. So to work out how many hours it is, I'm going to divide it by 11, 0.9. So that's 0.9 hours. So let's switch that over to hours, minutes, seconds with this function here. And it's 54 minutes. There we are. So set a timer for 54 minutes. Okay, let's have a look. Let's go back. So, okay, so 60 kilometers from home. So I'm going to do 60. So let's see. So should we just try and do it all in one go? I mean, to be honest, this is kind of why I like the RPN calculators, is that I can work out as I go along. I've kind of worked out now what I need to do. So actually the algebraics have an advantage here. But if I hadn't done that on the RPN, I would have to sit down and probably write out a formula for this. But let's give it a go. So what I did was I did 60 times, and then I did 30 divided by 100. What's quite nice about these older algebraics is that they're a bit more like RPN in some ways, and that they show you the intermediate results. So I know that hasn't done, so the 60 times that hasn't happened yet. But this is how much I need to get home. I'm then going to subtract it from 64.7 times. I'm going to do times 0.15 because I don't want to muck around with percentages on this calculator. Okay, I'm going to hit equals. Okay, so I think that was the same as what we got before, and then we need to add 20% to that. So actually adding 20% to this is a bit awkward. I don't want to type that number in again. I mean, I guess we just multiply it by 1.2, but it is a little bit, I mean, yeah, there isn't obviously an easy way to do that. I mean, okay, so if you were doing it, if it was a more awkward percentage value, you could do times, okay, so it's 20%, so you could do times brackets 100 plus 20 and then divide that by 100. Oh no. Yeah, okay. That was a failure of not anticipating how many parentheses I would actually need. So it did that multiplication before I could divide that. All right. Let's try that again. 60 times 30 divided by 100. And then I'm going to subtract all of that. 64.7 times 0.15 equals. So we're back to here again. Okay, so, all right, let's just times it by 1.2. There we go. I mean, that one, you're kind of doing some calculations in your head there, I suppose. But what I was going to do was 100 plus the 20%, divide it by 100, and then multiply that. But you do have to anticipate your brackets. So that's 20% added, divide that by, now, do you see, when I hit divide here, it's not showing me answer, it's just giving me the number and then the divide enunciator there. So actually, in some ways, I think this is superior in many ways to the latest ones. You know exactly what you're dividing. Divide it by 11. There we go, 0.9. And it's this button here. And that's 54 minutes, which is the same. Yep. Okay, let's move on to the 115. So 60 times 30 divided by 100, subtract 64.7 times 0.15. Okay, now I want to multiply all that by 1.2, so I'm going to have to go back and insert a bracket. Okay, let's go back again. Yeah, that's right, isn't it? Okay, so times 1.2. Can we do all of it? No, we just need to divide this now by 11. Not sure, do I need another bracket for that? I don't think I do. Okay, just in case, let's do another bracket. Divide it by 11. Yeah, we've got that. We've got a button here to tell you how many minutes. 54. Okay, excellent. Right. Now then, the class whiz. So I know the formula now, which makes it easier, I think. So, okay, should we try doing this the math print way? So there we are, 60 times 30 over 100. So we're going to subtract 64.7 times 0.15. All of this I want to times it by 1.2, so let's go back. See, actually, even though it's math print, and that is meant to be, you know, people will say this is easier than the old algebraics, but actually you still end up moving around a lot using the cursor keys. 1.2. Okay, now I want to divide all of this by 11. Can I do that? No. I don't know how I'm meant to tell it to... If anyone knows how I'm meant to tell it to put the bar underneath everything. No, that is not what I wanted. Okay. Okay, so let's insert another bracket there. One over there. Now I think if I hit this, yeah, okay, it does. So actually that hasn't really saved me any time. I've still had to go back and put a bracket there, but divide it by 11. And it's given it as a fraction. So yeah, I mean, I find this a bit annoying. There we go. Okay, so that's how many hours it is. I can see the symbol here for converting it into minutes. So will that work? Yes, there we go. 54 minutes. There we are. I have to say, actually, that one is probably the hardest one of the lot, despite it being math print. Okay, so that's comparing it to Algebraics. So this calculator then, can you use it in schools in the UK, and is it okay for exams? Basically, the answer to this, I think, overall is yes, but I'm going to caveat that with the fact that we need some clarification really on whether these calculators are allowed. The problem with RPN calculators is that they are often all very high end because HP made them for engineers and for people who really wanted to, you know, scientists, engineers. They weren't really designed for school children. And because of that, almost all of them are programmable, at least the ones you can get hold of. So if you have a look at the FAQs from the JCQ, and this is basically the Joint Council for Qualifications in the UK, they give advice on whether, what kind of calculators you can use. So first thing is they define the calculator as an electronic device whose primary purpose is to carry out mathematical calculations. I think that's quite a useful clarification there. Basically saying you can't use mobile phones, you can't use computers, that can also calculate. I think that makes sense. On the FAQs, so they've done some clarification of what they mean by during an examination. So the full regulations on calculators use this term during an examination. So we'll get onto that a bit later, but it basically... Okay, sorry about that. My phone ran out battery. So that's really about exam mode. Data banks, they've clarified, so you can't have a data bank on your calculator, but you are allowed constants, which is a useful clarification from last year, particularly since the latest firmware of the DM-15L has constants. So that is nice. It does exclude this calculator then. Right, so what else? So things that you definitely can't use in the UK are any calculators with symbolic algebraic manipulation or symbolic calculus. That is just not allowed. Although weirdly, a lot of algebraics will return sort of surds and fractions from trigonometric calculations, which I think is kind of bordering on algebraic manipulation. But there we are. Those, even the most basic ones, this will do. This will return trigonometric functions as surds. I mean, not all of them, just some. So what things do they not ban? Well, they don't ban graphing calculators, and they do not explicitly ban programmable calculators. So let's have a look at the full guidance. So the section 10 is on calculators. So specifically, what they cannot do is they cannot have a language translator on that, and by which I believe this means sort of modern languages, so translating, say, from French to English. This is not the computer term. You can't have symbolic algebra manipulation, symbolic differentiation of integration, cannot communicate with other machines on the internet. So now it also puts here, during an examination, a calculator must not give access to pre-stored information. This includes data banks, such as the periodic table, dictionaries, mathematical formulae, and text. Now, this is quite interesting. So it depends on how you read this as to whether you think a programmable calculator will be allowed or not. So if you wish to have this calculator compliant for an examination, my reading of this would suggest that as long as you clear your programming memory, and I'll show you how to do that, then it should be compliant for the exam, because during the examination you will not have access to pre-stored information. But there probably could be some clarification involved in that. So how would you make this calculator exam ready? So you would switch to programming mode, which is G, and then this one here, press F, clear program. That has wiped your programs, and then switch back again. And that's essentially cleared all your programming memory. It doesn't, I mean, it says mathematical formulae, so I would say that, that would include programming, but it doesn't explicitly say programs, which I think is a little bit strange. And actually, there are plenty of sharp scientific calculators that will be able to store formulae. They're fairly basic calculators. They don't have an exam mode, so for those ones to be compliant, I think that you would need to be clearing that calculator before you go into the exam. Okay, so that's, you know, my interpretation is that this calculator would be okay for an exam, but obviously there is this slight risk, particularly people don't know and don't recognize this model. Yeah. Okay. Right. So just to summarize then, so I think, you know, one of the advantages of RPN is that it does allow you to do free-form thinking. So there, you know, I feel far more confident just jumping into a problem with RPN and trying to work my way through it. And that confidence comes because you can just leave values on the stack. And the really nice thing about the stack is that you can manipulate it. You have numbers on there. I'm swapping X and Y. I can roll them down. This calculator has 4 levels on the stack. And it gives you some confidence that you can actually just work things out, work out interim results, and not have to worry about saving it to memory, although you can do that, of course. The other thing is that chaining calculations on RPN, I mean, it's really set up to do that. It's the only way to calculate on it, is to chain. And because of that, I think it's quite advanced. You're always chaining with the absolute value of the number that you're working with. The problem with the answer button or the last answer button on Algebraics is that they work in different ways. So we can see out the 3 Algebraics that we use this time, the answer buttons did something a little bit different. And you've got to be quite careful as well because, for example, on some of the later Casios, changing the format actually counts as a recalculation. So if you calculate it and you find that your answer is not in the format that you want, and it's got answer in the formula, and you reformat it, you will be feeding that round back again, and you might not realize that. So with RPN, you're completely responsible for deciding how you interpret your formulae. It's you, it's not your calculator, which means you don't need to get involved in these arguments about whether juxtaposition should take a higher priority or not. I've got my opinions on that, and that means that my calculator choice would be limited to ones that agree with me. And I think overall it's quite quick and intuitive once you get the hang of it, because some people say it is confusing, but actually I don't think it is. You have the numbers here in front of you, and you apply the functions to the numbers. So all you're really doing is applying functions to numbers. So I want to times these 2 numbers, I press times. You put your data in there first, and then you do what you want to do with it. And that isn't particularly confusing. So what about the downsides? Well, so the biggest downside is that your teacher and your fellow students are unlikely to be able to help you with your calculator. You know, if you get one of these for school, you're probably going to be the only person there using it. Lots of other little things like fractions. This doesn't do fractions. Quite a lot I mean, there's no reason why RPN can't do fractions, and some of them do, but most of them don't. So it's not going to simplify fractions for you. You're not going to be able to subtract fractions. You're going to have to learn how to do that yourself and use the calculator to aid you with that. Programming as well. Programming it, I mean, there's no reason that an RPN has to be programmed in RPN, but they often are, and that makes for code that is very tricky to understand. I definitely concede that. Hopefully in the future we'll get more modern RPNs that actually allow you to program more regularly. The HP Prime, for example, can program in Python and in some other language as well, which is far more modern and doesn't look impossible to interpret. Although the HP Prime would not be, I mean, that would not be suitable for school. They're expensive, and also they don't have, it looks like the latest Casios have got probability distributions. These ones don't have it. You may well be able to recreate it. I've got to admit, it's probably for further maths that you're going to need that, and I don't know how much you need it either. When I was at school, I think they were mainly provided on tables rather than expected for your calculator to do. But overall, RPN is very satisfying to use. There's a lot of heritage from HP here. Some things are really, really impressive, like the matrix and complex handling of this calculator is fantastic. So if I set, so complex mode can be, it doesn't have to be explicitly set, but you do need it to be in complex mode. So for example, if I made a complex number 0, 0, and that creates the complex number, it switches to the complex flag being on. But try this in almost any other calculator. Type in 1, change sign, and take the natural logarithm of that, and it will show you pi I as the result. There's actually remarkably few calculators that can do that, and if they can do that, they won't be able to calculate this, which is to take the inverse cosine of pi and then take the cosine again, and it will return you pi, going through an imaginary number in between. So I think there might not be any other calculators that can do that, even the big graphing Casios and Texas Instruments. So there's that heritage of HP, who were, they were the best calculators back in the day, and this is a clone of their calculator. So yeah, that sums up my summary of this calculator in terms of comparing it to Algebraics, and also whether it's suitable for use in exams in the UK. That's it. Thank you for listening.